Okay, let us see another example still when they give us the magnitude of the velocity and then they give us the direction in terms of the angle. So the resultant of two velocities is 10 kilometers north 30 degrees west. If one of the velocities is 10 kilometers due west, find the magnitude and the direction of the other velocity. So now we say, now they are giving us the resultant. So meaning our resultant, they are giving us the resultant of two velocities 10 kilometers north 30. So this is the north. In the north is going 30 degrees to the west. So this one means to the west. So north 30 to the west. This is the west. So you see that from here I go 30 to the west. Then that is 10 kilometers. So we said after this you resolve this velocity there into the vertical component and then the horizontal component. So you see this one is adjacent, so adjacent goes with the cos. So you get the velocity 10, then cos 30 degrees. Then this one is opposite to this angle, so this will be now the force, which is 10, the velocity. Because it's opposite goes with sine 30 degrees. So now meaning my result, and because this is our resultant, will be given a vertical component, then the horizontal component. So my resultant will be the horizontal component, since it's going in the negative, so it's going to be negative 10 sine 30 degrees. Then this one, the vertical component, is going in a positive of y. So we take now to be 10 cos 30 degrees, and so that is the resultant. Now, when we come now to this, if one velocity is 10 kilometers due west means you are going towards the west. So due west means this one will come here and then goes, this is what we call due west. So due west here 10 kilometers per hour. So meaning this is purely horizontal force. So meaning that now my V1, the first velocity, we shall give it in Vx still, Vy. Because this is purely horizontal, it's going to be negative because it's going in this direction, but it's 10. Then the vertical component, we said whenever you see that the velocity is purely horizontal, then the vertical component is always 0. But we know Vr is equaling to V1 plus V2. So you're interested in getting V2. So mean that now our V2 will be equaling to Vr minus V1. So this will give me my Vr. Okay, my Vr, which is negative 10 sine 30, another sine 30 by the way is 0.5, but anyway. Then 10 cos 30 degrees, then minus, this one is negative 10, then this one is 0. So now from there, our V2 is going to be, you get this is going to be a 5, then this one will be, then this one is the 5 root 3. These are special angles. Cos, okay. Let me put for you sine 30 is a half, then cos 30 for it is root 3 of 2. And put here 3 over 2, the 2 goes with this, you get 5 times root 3. That's why we have that. So it implies that all of them are positive. So if we have sketched this now, all of them are positives. So meaning this one is going to be my 5 root 3, and this one is going to be 5. So now I want this result. So if I want this as my alpha, this is the angle I'm going to set from there. Okay, so this one is going to be my V2. So you can see that now my V2 is going to be the square root of this, then plus 5 root 3 the whole square. So 25 times the 3, that is 75 plus 25, that's 100. So our V2 is going to be 10. kilometers per hour. As simple as that. Okay. Then from there we can get the angle we need to set. So from there our alpha is going to be tan inverse. Now you see my opposite if I do this to this force. My opposite, which is going to be 5, over the adjacent, which is 5 or root 3. Always our angles in bearing should be given to the vertical line or the north line. That's why I'm setting this to be alpha here, not here, because we read them from the vertical. So from there, my alpha, that I think is going to be 3rd, because there is a special angle. So alpha is the 3rd. So now, what does it mean? It means that now, this velocity here is 30 degrees there. That's our V2. This is our north. This is our east. So let me make it a bit bigger so that it's not that small. Okay. So if I'm to draw that, you see this is how it's going to be. This is going to be now the 30 degrees. This is our north. This is our east. So we are getting 30 degrees north, 30 towards the east, and this is our 10 kilometers per hour. So now the course we should say, the direction of this is north, 30 degrees towards the east. As simple as that. Okay, then when you come to method 2, let us use the vector triangle. Okay, now in the vector triangle, now you see they are giving us first this force, and then we have the resultant going in that direction. So I start with the force I have. This is going to be my first force. My first velocity on the force, which is going due west. So it's going due west. This is 10 kilometers per hour. You use one method. You use only one. Okay, so when it is there, I think it will come to certain. But now, because we have our resultant, so meaning our resultant is going to be somewhere here. So this is going to be my resultant. Or, if you don't want that, you can base on this, then you can see that my resultant for it is going in this direction. Then you can extrapolate it to this side. Let me show you that here. Okay, so now, if I'm to redraw this a bit down, so that you can see how we do what we do, and using the vector approach, you come to our force, this one. So you see this is going to be our force, it's going to be, this is the eastward. So this is going to be eastwards. So this force here, this velocity is 10 kilometers per hour. So now, you put them in one. So you come and also put our force there. So this is going to be our force. So this one, remember this is R north, so this one was 30 degrees. And for this one, it was still 10 kilometers per hour. Now, from there, you see this velocity go coming this side, so meaning if you want the other velocity is going to come like this, it should go here. So because this is the resultant, so this is our resultant velocity. So this should come and then go the other side. So mean that this one is going to be here. And now for it has to meet this one. So it has to come and then it meets this one there a bit. Okay, so now after we are drawing this, then after, remember, when this first comes here, it's going to be something like that. Okay, so now we're always interested in the angle we set from the north line. So let us call this alpha, and I call this angle any angle you want. Okay, let me call it theta. I'm not interested in theta. Now, because this is 30, you see when I go like this one is going to be 30 degrees, and then this one is going to be alpha. Okay, so my velocity, this velocity is going this side, and it's the velocity I'm looking for, V2. This is our V1. Okay, now from there, you see, this one, because this one is going this side towards the west, means that this one is going to be, if this is 30, then this one is going to be 60. So now we have this, we need this, we have 2 of this, and we have there. So there you can use the cosine rule. The cosine rule. The cosine rule. So from there, we say our this v squared 2 is going to be these 2 opposites plus 10 squared minus 2 into 10 into 10, then cos of the angle between them. We saw all these, because I know the videos are there, you can go in the place and look out for them. So from here, our v squared 2 is going to be, when you press that on the calculator, you get 200, that's 200 cos 60. It's going to give us 100, and therefore our V2 is going to be 10 kilometers per hour. If you understand the method approach, it's always very easy to get the answer. So now we have that V2. Now it's that we need this angle. This angle is what I'm interested in, not this one. I'm always interested in the angle this vector makes with the horizontal. So from there, you see, I need this angle. I have the whole of this now here. It's going to be theta plus 30 degrees. So I need this angle. So I have this, I need this, I have this, I have that. So from there, we use the sine rule. Our sine rule says, now we get this, we shall get V2, we shall get V2, which is, okay, V2 over sine 60 equaling 2. Now this one I need, so I get 10 over sine of alpha plus 30 degrees. So my V2, so there I have 10, and then cross multiply, I have V2, which is 10. So V2 sine alpha plus 30 degrees equaling 10 sine 60. That means so I have 10 sine alpha equaling 10 sine 60. So from there, you see this one and this will cancel, remaining with sine alpha plus 30 equaling sine 60. So meaning these two angles are equal. So now alpha plus 30 degrees is equaling 60. And so my alpha becomes 30 degrees. So if I have now my alpha, it means that now this is the case I'm adding. So I have my alpha. This alpha has 30 degrees. This is my north. This is my east. And I have this as 10 kilometers per hour. The V2. So meaning the direction I should take is north. 30 degrees from the north, 30 degrees towards the east with ease. So the vector approach, I mean the triangle of vectors, is very easy. This one is, it gets the answer but a bit longer. But this one is always easier. So that's it, members. Wish you well.